Alright, tonight's subject is going to be nanotechnology and how it's going to apply to the future. I'm going to go through a bunch of pictures here, so try and keep up. It should be a lot of fun, actually. Alright, starting off, where did I put it? Alright, this is a nanoparticle. It looks pretty simplistic, it just looks like a simple sphere, but it is significant because we can repeat this hundreds of millions of times, and we will get the same result every time. And it's also the smallest scale that we can do this on. What does that mean? It means absolute consistency in materials. Most materials that we make nowadays are pretty much random on a nanoscale. Even the highest quality Pyrex bowls, the windows to the space shuttle, we can predict roughly how it's going to be, but it's still a natural crystalline structure, which still has a lot of randomness, but nanomaterials won't. I mean, it's just as simple as that. Let's see where we have nanotubes. Nanotubes are an extension of that. You can see similar patterns there. But these are a little bit more useful because they can draw out into long strands, which you can do things with, like tie them into knots or create threads and weave those threads together. Or you can even trap things in these spheres or tubes for transport, for safe transport. That's what they're trying to do with cancer. They'll put cancer-killing drugs in those tubes or spheres and trigger them to be released only in the tumors, which means that the patient doesn't get nearly as many bad side effects. They're still working on that, obviously, because mass production is still really slow on these things, but it is coming along very quickly. Let's see what else. We've got other nanotubes here. Let's see. And then we've got nano pumps, the most basic nanomachines. This one, for instance, it looks pretty simple, like just a couple of gears, a little bit of clockwork there, but you have to consider how small it is. That's the most significant part, is that we can do these things repeatably on such a small scale, and it's getting cheaper. Let's see. Nano pump. When this was animated, the lavender part at the top there was actually spinning independent of the rest of it, and it uses almost no energy. That's just because it's so small. And that, this doesn't look like it would be terribly useful, but it's just one part, and you can count the number of atoms involved in this, and we are almost capable of building something like this. Let's see, what other nanomachines do we have here? We've got this one, which is just once again, it looks like just a couple gears, but also you have to consider the scale that this is on. And this would just be one of millions of parts of a much larger and more complex apparatus. This one is slightly more complex. It looks a bit like a differential, except on an atomic scale, obviously. Let's see. Then we've got, oh, come on. This one is, it's a little bit harder to understand. I'm not quite sure what this is, but once again, this is something that we will theoretically be capable of producing in the near future. And the goal would be something like this, a nanofactory. This, we can barely make out how it's supposedly made of different specific materials. You've got the operating levers and arms, and you can see it reduces in size. You start off with the very small, where you're working with single nanoparticles, and you get those all stuck together to make larger and larger nanomachines, and eventually these largest arms will be carrying finished nanomachines and sticking them together on larger devices. Let's see here. Here's a closer up view of a different part, or a different type of nanofactory. You can see in the top middle here there are just random nanoparticles or even molecules, and then you've got the star-shaped pinwheels that are putting those onto a conveyor belt that's running kind of down the right side, and that conveyor belt is carrying the same devices. It's the same exact device, just being produced many, many, many times per second. And then you've got hundreds of these types of devices all lined up, and all of that would fit in less than an inch, all told, theoretically, once it's completed. And that would produce several hundred million units per hour. Granted, these units, like I said, are very small, and you need several hundred million of them per device. Let's see here. Let's see, we got the nanofactories. We're getting up to, an example of other nanoparticles. We can control gold nanoparticles to the point that we can create specific colors. If we turn gold nanoparticles into a dust, we can make gold into this bright lime green or yellows or purple colors. And that's just an example of that we can repeat this process and that we can control the properties of various things. Let's see. Here's another good example of a nanomachine. This one would be theoretically using DNA strands, which we already know that DNA and lots that's involved with DNA is very good for nanotechnology because it's set a lot of big precedents. Alright, now the nanofactories would likely be producing, amongst other things, nanobots. This is probably not exactly what a nanobot would look like. However, it just gives you an idea as to the scale. That would be, maybe a virus or a cell there that the machine is grabbing. I just chose that one because it's pretty. This is a little bit closer to what they might actually look like. You'd have a couple of these orbs, slightly different shapes stuck together. One would be something carrying the medicine, as it looks like what this one is. Another one would be like some sort of system of propulsion. Another one would be kind of like the brain or whatever is going to target what you need to get that medicine to. And that would be a medical example of a nanobot. Let's see here. What else do we have? Come on. Let's see. After we get done producing nanobots, we could couple this technology to something else that is being developed, and that's called rapid prototyping. Let's see. Here's just a little montage that a company put together. These things have been rapid prototyped. Now what that means is some of these were done with stereolithography, which is basically you have a solution, a polymer-based solution that you shine two lasers in, and where those lasers meet, that solution hardens. You can produce almost any shape